the numerous editions, I think something like 17 editions of the Silva-Silvarum, which is a work in natural history during that period. The Novum Organum gets very little attention. It's not translated into English. There's an abridgment, a very short abridgment that was published as an appendix to the Silva-Silvarum, but the full work, I think, was not published until somewhat later.
Sorry, you mean then?
Then, right? Yeah, but of course it's been translated a number of times since. And in fact, one might argue that after the publication of the Novum Organum in 1620, Bacon really sort of set that aside. The Novum Organum that was published in 1620, of course, was incomplete. It was not the full project. It left off in the middle of part two. Bacon turned his attention at that point to the natural histories. Even so, it seems to me the Novum Organum and Baconian method is itself really a 19th century concern rather than one in the 17th century. But even so, I would like to go back and look at what the method looked like to Bacon himself as he was setting it out, and the way in which it was connected with other elements of his project. I'm going to work through a number of these passages in the handout. What is the project of the method? What is it that Bacon is trying to discover in the method? And he suggests that and this is the first quotation on the first page, on a given body to generate and superinduce a new nature or new natures is the work and aim of human power. Of a given nature to discover the form or true specific difference or nature engendering nature or source of emanation is the work and aim of human knowledge. Okay, so the point is, in terms of power, to superinduce a new nature or natures on bodies. And in terms of knowledge, it's to discover the form of those natures. So there are two technical terms here, nature and form. I'll come back to them in a moment. But just to point out, and the point is actually to change bodies in nature, to superinduce particular nature on a body, and we do that by knowing its form. He also talks about subordinate to these primary works are two others that are a secondary mark. To the former, the transformation of concrete bodies, so far as this is possible. To the latter, the discovery in every case of generation and motion of the latent process carried on from the manifest efficient and manifest material to the form which is engendered. And in like manner, the discovery of the latent configuration of bodies at rest and in motion. So we have two more technical terms being introduced here: latent process and latent configuration. Latent configuration and latent process. Okay, they're in the first quotation on the handout. Okay, and I'll come back to those. But these are important technical terms that Bacon is introducing right at the beginning. So first question, what is a form? What does Bacon mean by a form? And this is the quotation in the next quotation, the Novum Organum, section 4, part 2, section 4. We must therefore consider if a man wants to generate and superinduce any nature we still don't know what a nature is, upon a given body, what kind of rule or direction or guidance he would most wish for. For a true and perfect rule of operation, then, the direction will be that it be certain, free, and disposing or leading to action. And this is the same thing with the discovery of the true form. For the form of a nature is such that given the form, the nature infallibly follows. Therefore, it is always present when the nature is present, and universally implies it, and is constantly inherent in it. And again, the form is such that if it be taken away, the nature infallibly vanishes. Therefore, it is always absent when the nature is absent, and implies its absence, and inheres in nothing else. So, if we have a given nature, and remember, I haven't said what a nature is, but if we have a given nature, the form of that nature is that which is necessary to produce it, and that without which it is not produced. So it is a rule for producing a nature, it appears. But what exactly is it that he means by a nature? And here I want to look at the next quotation. And he's talking about a rule or axiom for the transformation of bodies. The first regards a body as a troop or collection of simple natures. And now we're finally going to have some examples of what it is that a simple nature is. In gold, for example, the following properties meet. It is yellow in color, heavy up to a certain weight, malleable or ductile to a certain degree of extension. It is not volatile and loses none of its substance by the action of fire. It turns into a liquid with a certain degree of fluidity. It is separated and dissolved by particular means, and so on. For other natures which meet in gold, this kind of axiom, and an axiom is simply going to be, again, a rule for producing a transformation, therefore deduces the thing from the forms of simple natures. For he who knows the forms of yellow, weight, ductility, fixity, fluidity, solution, and so on, and the methods for superinducing them and their gradations and modes will make it his care to have them joined together in some body, whence may follow the transformation of the body into gold. So this is the picture, and you can see this sort of connection with alchemical thought at that point very clearly. There are a certain number of what he calls simple natures in the world. And given kinds of substances are characterized by configured by collections of simple natures. And each simple nature has a form. And that form is going to be a rule that allows you to actually produce that simple nature in a body. So if we want to transform a given body into gold, we have to know what simple natures make up gold, and then the forms of each of those simple natures. So you have already a kind of metaphysical picture of the world. You have the world, everything is characterized by a collection of simple natures, and each simple nature has a form, a rule that you can use to produce it. Okay, that's form and simple nature. How about latent process and latent configuration? He talks, to continue in section 5, says the second kind of axiom, which is concerned with the discovery of the latent process, proceeds not by simple natures, but by compound bodies as they are found in nature in its ordinary course. So normally we don't actually produce gold in the laboratory by putting together forms. We find it in the ground as produced by nature. As, for instance, when an inquiry is made from what beginnings and by what method, by what process, gold or any other metal or stone is generated from its first menstrual rudiments up to the perfect mineral, or in like manner, what process herbs are generated, etc. So the latent process is going to be the process by which in nature, gold, for example, is produced in the ground. And we can actually produce gold perhaps by imitating in the laboratory. The the process by which gold is actually produced in the ground. And that is, and the process is itself the latent process. Latent because it is hidden, but still it's going to be the process by which it actually happens in nature. What he calls a latent configuration, which was mentioned earlier in section 1, is in section 7. This is the first quotation on page 2. And the latent configuration is here. I won't read this quotation, but it's basically the underlying structure of bodies. There is going to be some structure of parts that produces, that characterizes, for example, gold, and that will be its latent configuration. Although he doesn't say as much about that as he says about the other, as about these other notions. So there is here, and this is, I think, very important, a kind of underlying metaphysics. There are simple natures. They come together to form complex bodies. Each simple nature has a form or a rule for producing it, which is presumably connected with a particular latent configuration. Gold can be produced by using these forms or rules to produce a body that has the appropriate simple natures, or it can be produced if we know the latent process that can lead up to the appropriate collection of simple natures coming together in the appropriate way. We can either, by knowing the forms of each of the individual simple natures, put them together in a single body, or we can look at nature and see how it is that gold is produced in the ground and try to imitate that process. And the resulting organization of knowledge is what he gives in section 1.9 and section 2.9, which is the second quotation on page 2. And he talks about the division of philosophy and the sciences. And this is something that you find in a number of other Baconian texts as well. Thus, that the investigation of forms, which are, in the eye of reason at least, and in their essential law, eternal and immutable, constitute metaphysics. And let the investigation of the efficient cause and of matter and of the latent process and the latent configuration, all of which have reference to the common ordinary course of nature, not to our eternal fundamental laws, constitute physics. This is actually very interesting. The term form that Bacon uses is, of course, a term that one finds in the Aristotelian philosophy. That's not what Bacon means by it exactly. It's not exactly the same, because for Bacon, form is connected with actually producing an effect, which it's not in the Aristotelian philosophy. But still, he uses the term metaphysics and the term physics. And to these let there be subordinate two practical divisions, to physics, mechanics, and to metaphysics, what in a pure sense of the word I call magic, on account of the broadness of the ways in which it moves in and its greater command over nature. So mechanics is using basically our observation about latent process and latent configuration to control nature. So mechanics is applied physics, and magic is the control of nature through knowing the forms. So you might call it applied metaphysics, something about which Doina has written, I think, at great length. But I do think that ultimately what Bacon is concerned with, the highest science for Bacon, or I won't put it that way, but certainly one might say that the goal of the method is to produce a magic. That's to say, control of nature through knowing the true forms of things, and the true the true forms of things, and the true simple natures as well. So the first point that I want to make here is that Bacon's method is a procedure for producing knowledge as constrained by this underlying metaphysics. It is not neutral in that respect. Bacon is coming to the project of a method with an idea already of the basic outlines of what it is that metaphysics, or what the metaphysics of nature looks like. The idea of forms, simple natures, latent configuration, and latent process is all, part and parcel. Method is the Baconian method is a procedure for producing a science understood from the perspective of this method. One question, though, that's I think very, very interesting to ask, though, is how do we know that this metaphysics is the right metaphysics? And I don't see a way in which the metaphysics itself can be subject to Baconian methodological investigation. So in a certain sense, it's something that he comes to. He comes to nature already with an outline of how it is that things have got to be. Maybe he doesn't say what exactly are the simple natures. And we certainly have got to do empirical investigations to figure out what the forms are. But how do we know that that's the right way of thinking about nature from the beginning? And he doesn't ever really, to the best of my knowledge, there certainly are investigations of what the simple natures are and what the simple motions are and things of that sort, but he never, to the best of my knowledge, attempts a justification of the basic metaphysical framework. Okay. In part one, in part two of the Novum Organum, Bacon actually works out one example, and that is, of course, the form of heat. There are other, it's important that this, first of all, that this is an investigation within the context of the general metaphysics that I outlined. The question assumes that heat is a simple nature. And second of all, it assumes that it has a form in the precise technical sense, which is to say necessary and sufficient conditions for producing it in anything. And so it is a question that is framed in terms of the metaphysical framework that Bacon starts out with. Note here that there are other investigations in principle that one could do as well. For example, about latent processes and latent configurations. He doesn't actually give any examples of how it is that the method might be applied to finding those sorts of things. The only example he gives is finding the form of a particular simple nature. Now, let's go through sort of an outline of how it is that this investigation goes. So the first stage, Bacon says, and this is the third quote on page 2. First of all, we must prepare a natural and experimental history, sufficient and good. And this is the foundation of all, for we're not to imagine or suppose, but to discover what nature does or may be made to do. So we have to go to the world. We have to go to observation and experiment to find out what the world is really like. But what's important here is that this involves an orderly investigation. It isn't simply a sequence of observations taken in a sort of random and unreflective way. He talks about in section 10, he talks about it, but natural and experimental history is so various and diffuse that it confounds and distracts the understanding unless it be ranged and presented to view in a suitable order. We must therefore form tables and arrangements of instances in such a method and order that the understanding may be able to deal with them. So the point is, and this is, I think, what Bacon saw as one of the central innovations in his project, which is to say, natural history has got to be done in a very careful and structured way. It's important to do lots and lots of experiments, but you have to order them in such a way that you can actually derive conclusions from them in a suitably rational and orderly way. And so what Bacon proposes is that we organize things in a sequence of tables. And in the example of heat, he suggests that we use 3 different tables to organize the observations that we make with regard to heat. The first of these is what he calls the instances agreeing in the nature of heat. And which is to say just simply a list of things that are hot. Where else do you begin? And so he goes through, so I give the first 5 of them there. The rays of the sun, especially in the summer and at noon. The rays of the sun reflected and condensed as between mountains. Fiery meteors, and meteors are of course, atmospheric phenomena. Burning thunderbolts, eruptions of flame from the cavities of mountains, let's say volcanoes, and on and on and on. And he does also later on include things like hot peppers, which are hot to the taste. He does include hot, the heat that you experience when you wear a fur, for example, and things of that sort. All of these are instances of heat. Later, he's going to sort of sort out which are really heat and which are not. But the first idea is you put all of these things together. The second table is what he calls the table of deviations, or instances in proximity where the nature of heat is absent. What does he mean by instances in proximity? Well, what he does is we have a whole long list of, in the first table, the instances agreeing in the nature of heat, a whole long list of hot things. And in the second table, we have a list of similar things which are not hot. So, for example, the first one is the rays of the sun, especially in summer and noon. So the first in the instances in proximity are the rays of the moon and stars and comets, not found to be hot to the touch. Indeed, the severest colds are observed in the full moons, etc. So the rays of the sun are hot, the rays of the moon are not. The rays of the second in the first table is the rays of the sun reflected and condensed as between mountains. And the second is the rays of the sun in what is called the middle region of the air, which do not give heat. Say again, a similar instance, but in that case, we don't have heat. And so on, and it goes through all of the instances of the first kind, giving contrasting instances. And the third table is what he calls tables of degrees or comparisons in heat. And there he talks about instances in which things are more or less heat. Thirdly, we must make a presentation to the understanding of instances in which the nature under inquiry is found in different degrees, more or less. So he talks about things that are more or less hot. And this ends the part of the process that deals with natural histories. And the point of these tables is to direct the investigation in a rational way. And I'll call your attention to one of the most famous passages in the Novum Organum, the analogy with the ant, the grasshopper, and the bee, which is the first quotation on page 4 of the handout. Those who have handled the sciences have either been men of experiment or men of dogmas. The men of experiment are like the ant. They only collect and use. The reasoners resemble spiders who make cobwebs. I'm sorry, it was the spider, not the grasshopper. Who make cobwebs out of their own substance. But the bee takes the middle course. It gathers its material from the flowers of the garden and of the field, but transforms and digests it by the power of its own. And that's what it is that we're supposed to be. We're not empiricists. We're not dogmatists. We are putting these together to form a more perfect way of dealing with nature. And the way in which we are beginning with we're beginning with observation, we're beginning with experiment, but we're ranging them into rational tables so that we can then be able to draw conclusions out of them. So once we have these three different tables, Bacon proposes the inductive step, and this is how it is that we are going to actually begin to draw some conclusions about the form of heat from the observations that we've made. And the first thing he does is set up an exclusion or rejection of nature from the form of heat. So we're going to look at the things that are hot and the things that are not hot. And we're going to exclude possible forms. So on account of, the first one, this is in the middle of page 4. On account of the rays of the sun, reject the nature of the elements. Here, obviously, he has in mind the Aristotelian view that some elements are by their nature hot. You know, there are hot and cold, wet and dry are the two contraries that define the four elements for Aristotelian natural philosophy. And so air and fire are by their nature hot. And so one might say, from the nature of the elements, you know, hot things are simply hot by virtue of the nature of being either air or fire. And but from the fact that the rays of the sun, which are neither air nor fire, are hot, we can exclude that. And on account of common fire and chiefly subterranean fires, which are and we know they're subterranean fires because of volcanoes and so on, we reject the nature of the heavenly bodies. We can't say that heat comes from the nature of the heavenly bodies because there are terrestrial fires and subterraneous fires that are not hot. So that turns out to be an incorrect hypothesis about the form of heat, and so on and so on and so on. And in this way, we can use the observations that we've made in the tables to exclude certain things as telling us about the nature of heat. And from that, Bacon derives what he calls the first vintage concerning the form of heat, which is presumably a claim about the nature of heat, of the form of heat, that is not contradicted by any of the observations that we've made, and is supported by all of them. I won't make a defense of that because I think Bacon skips over a whole lot here. And how exactly, it's fairly clear how it is that the table of exclusion is constructed. It's not clear to me at all how exactly it is that the first vintage is made. But nevertheless, presumably you're supposed to look and you're supposed to see that all of the instances that you have in your tables agree with this first claim about the nature of heat. And what the idea is that the form of heat is something that is present in all of the experimental instances of heat, is absent in all of the experimental instances in which there is not heat, and is more and less in all of the instances in which there is more and less heat, right? So this is the way in which you're supposed to use those tables to derive the first vintage. And the first vintage is from the survey of the instances, all in each, the nature of which heat is a particular case, appears to be motion. This is displayed most conspicuously in flame, which is always in motion, in boiling or simmering liquids, which are also in perpetual motion. It is also shown in the excitements or increase of heat caused by motion, as in bellows and blasts. Okay. Heat is motion. What does this mean? And that turns out to be very, very interesting. This has, of course, been interpreted as Bacon discovering the kinetic molecular theory of heat. In a certain sense, it's one can see why it is that you might think that. That what Bacon is saying is that hot things are things whose parts are in motion. And so heat is just simply the motion of the parts, which is, in a certain crude sense, kind of what it is that the kinetic molecular theory of heat is. But here is the second place in which I want to show that Bacon's method really is very much dependent upon a certain metaphysical view of nature. Because what he means by motion is not at all what it is that you think that he might mean by motion. And is very much connected with certain earlier animistic views of the world. So what I would like to do is look briefly at, Bacon, further down on that quotation, which extends onto page 5, Bacon says heat is motion. And then he goes through and says, and here are some specific differences that characterize motion, the motion that constitutes heat. The first difference then is this. Heat is an expansive motion whereby a body strives to dilate and stretch itself to a larger sphere or dimension than it had previously occupied. This difference is most observable in flame, where the smoke or thick vapor manifestly dilates and expands itself into flame. Already this is beginning to look sort of weird. This does not look like, say, Descartes' conception of local motion. Second difference is a modification of the former. That is, heat is a motion expansive or towards the circumference, but with this condition that the body has at the same time a motion upwards, for there is no doubt that there are many mixed motions, etc. The third specific difference is this, that heat is a motion of expansion not uniformly of the whole body together, but in the smaller parts of it, and at the same time checked and repelled and beaten back, so that the body acquires a motion alternative, perpetually quivering, striving, and struggling, and irritated by repercussion, whence springs the fury of fire and heat. Okay, and the fourth specific difference is a modification of the last. That is the preceding motion of stimulation or penetration must be somewhat rapid and not sluggish, and must proceed by particles, minute indeed. Okay, so we have 4 specific differences. These are the kinds of motion that Bacon says constitute heat. Heat is motion, but motion of these specific sorts. What's interesting here is now I want to turn to a section of the Novum Organum later, section 48 of part 2, where Bacon actually goes through, this is one of the longest aphorisms in the Novum Organum, where Bacon actually goes through and gives, I think, 18 or 19 different kinds of motion. And none of them are local motion. These are all various kinds of animistic conception of motion, where the idea is that bodies have certain appetites, desires, tendencies that are manifested in various ways. Those are what he means by motions. And I've chosen 3 of them from that listing, the 4th, the 7th, and the 18th, which correspond exactly to the 4 different kinds of specific difference that Bacon indicates for the kind of motion that constitutes the motion of that constitutes heat. So the 4th motion is what I have given. This is on the bottom of page 5. It's what I have given the name of motion of matter, which is in some sort the converse of the last name motion. For the motion of liberty, which is the previous one, bodies dread, loathe, and shun a new dimension. These are Bacon's animistic terms, or a new sphere, or a new expansion or contraction, and strive with all their might to recall or recover their old consistency. On the contrary, this motion of matter, bodies desire a new sphere or dimension and aspire thereunto readily and quickly, sometimes in the case of gunpowder, with most violent effect. And that, it seems to me quite clearly, is the kind of motion that he's referring to in the first difference. And it is, very obviously animistic. Bodies have desires, appetites, wants. The 7th motion be what is called the motion of the greater congregation, by which bodies are carried toward masses of like nature with themselves, heavy bodies to the globe of the earth, the light to the compass of the heaven. And that, I think, is what's going on in the 2nd difference. And then the 18th motion is what, by the way, that whole section is definitely worth reading because it's really fascinating. The view of nature that comes out of this. It'd be what he calls the motion of trepidation. But in searching carefully everywhere for the appetites of natural bodies, this motion comes before us and ought, it seems, to constitute species itself. So motion might be called perpetual captivity, and it occurs when bodies that have not quite found their right place and are not yet altogether uneasy keep forever trembling and stirring themselves restlessly, neither content as they are nor daring to advance further. And this, it seems quite clear, is what he has in mind in the 3rd and 4th specific difference. And again, in an obviously animistic conception. So this is not, it seems to me, the kinetic molecular theory of motion. What's interesting here is that I think this animistic conception of motion, which this text was certainly available, it was not suppressed, but just simply not noticed. And there's another, by the way, there's a paragraph in part 1 of the Novum Organum, which is shorter but similar. But, it just simply completely dropped out of the interpretations of Bacon. But it is what I think links, or one of the strong elements that link Bacon to, the late 16th century natural philosophers. One finds it in Gilbert, who is a figure that Bacon refers to quite often. One finds it in Cardano, who is a figure that Bacon sometimes refers to, but one also finds it in particular in Talesio, who is late 16th century natural philosopher who Bacon actually wrote a fairly extensive essay about, and whose work Bacon knew quite well. He didn't agree with him completely, but he was obviously somebody very important to Bacon, and I think for Talesio the central physical dichotomy that explained everything in the world was heat versus cold. And I think that, well, obviously one reason why it is that Bacon is looking at heat has, I think, to do with the Aristotelian tradition and the relationship between hot and cold in the definition of the elements in Aristotelian philosophy. But I can't imagine that he also didn't have Talesio in mind. And given that I've gone on a bit, let me just simply call your attention to the last couple of quotations from Talesio. This is from the 1570 edition of the De Rerum Natura. There was a later edition, but this is the only one for which there's anything translated into English. And the first quotation there begins by saying, "It's quite evident that nature is propelled by self-interest," and it's obviously an animistic conception of nature. And in the second, he talks about the differences between hot and cold, and heat's power makes the subject thin and light. By contrast, cold thickens things that it occupies. Thus, it is evident that hot and cold strongly abhor one another and are contrary to one another. There is an interesting and important difference, I think, between Talesio and Bacon. For Talesio, heat is the cause of motion, but is not identified with motion. For Bacon, heat is motion, and that is an interesting difference. But I think that it's quite clear that Bacon is absorbed a great deal from Talesio, and in many ways is in dialogue with Talesio. So just a couple of words of conclusion. I think it's interesting here. Bacon's method is very closely tied with his metaphysics. And this in two ways. First of all, the metaphysics of form, simple nature, and so on is, I think, at the heart of Baconian method. His is a method for finding nature as understood in this metaphysical way. And second of all, the animistic conception of the world underlies his only worked out example of the method. And one can argue, I think, that the way in which he draws from experiment to produce what he calls the first vintage, the form of heat, is very much colored by this animistic conception of the world that stands behind the method. And so in particular, I think a proper contextual reading of Bacon must recognize his own metaphysical commitments and his conception to a very different metaphysical framework than the one in which he was later interpreted. Bacon is, I think, basically a 16th century guy and not a 17th century guy. But it isn't even that simple. I think Bacon was later taken up by many later 17th century guys, and his thought integrated in with a mechanistic and experimental thought that characterized the later period, particularly the Royal Society and particularly Boyle. And this is a very different Bacon than the one that I've been talking about. How do we put them together? How do we balance? And in fact, it raises the larger question, what does it mean to give a contextual reading of Bacon when there are multiple contexts that lead to incompatible readings? And I think I'll just leave it at that. Thank you very much.
Thank you very much, Dan. And we have, bueno, tenemos tiempo para algunas preguntas, estos unos 10 minutos. Entonces, yo creo que juntaremos algunas preguntas y después que vaya contestando. Entonces sería Enrique, la doctora por acá, Alejandra. Sí, entonces, sí, Enrique.
Thank you very much, Dan. You never disappoint. Thank you very much.
Thank you.
Fascinating. In your view, what grounds in Bacon the appetites and desires?
I think for Bacon, they're fundamental. It's, if you look, for example, at the catalog of motions that he gives in book 2, section 48, from which I gave just a couple, these are just simply, these are fundamental characterizations of the nature of matter.
And do they track, or do they track anything? I mean, are they just...
What do you mean, do they track anything?
Well, are they anchored, right? On, say, something in Leibniz, right, in non-material, non-physical. I
don't think so. I mean, there are others who, the person who's written, I think at greatest length about this is Guido Giglioni, who's written at great length about Bacon's matter theory. And in fact, in recent years has been the one who has been most instrumental, I think, in calling people's attention to this sort of background. And you look, for example, in it's a more complicated picture than you get in Talesio. But in Talesio, I mean, he wants to reduce it to basically there are these two principles, hot and cold, and they are understood in terms of what Bacon would call motions, and these are sort of fundamental properties of matter as such. Well, no, these are the questions. What is the status of hot and cold for Bacon? For Talesio, they're not. Matter is something in which you have hot and cold. My first thought would be to look to Talesio and see Bacon as a kind of reinterpretation of that. But yeah, these are fundamental properties of matter as such.
Okay, now join, and we can get together a couple of questions. So we have like 10 minutes. So we can hear all the questions. So join. No? So.
Thank you very much. I have two questions that are related. So you asked, how do we know that this metaphysics is the right one? Do you think Bacon would have needed something more than just to know that it works in practice? So the very intertwined of speculative and operative sides of natural philosophy. If it works, then we must know that that is the correct axiom of the form. Do you think Bacon would have thought we need something more than that? We might not have access to something more if there is, but I'm not sure if Bacon wanted to say there is. And the second is, to what extent is Bacon metaphysically committed? Because yes, indeed, he says there are simple natures and I assume there are forms, but at the same time, he changes the list of simple natures from one work to another. So it looks very provisional at the same time. So they need to discover them, not to change them. So it's not theory laden in a strong sense. It looks like it's only in a technical sense.
I think, as far as the second goes, absolutely. This is all, a work in progress. And you look at various contemporary texts. I think fascinating text is the Apocadarium, right? And, where he gives a different catalog of motions, for example, than you get in but he's obviously not sure about the details. and is definitely working those out. However, he does seem reasonably sure about the overall framework, right? And the idea that there are simple natures, there are simple motions. And ultimately that's the thing, the forms have got to be given in terms of something more basic, and that's to say in terms of motions, it seems. And he does seem to have some conception of that there have got to be simple natures, even though we may not now know what they are. But what's interesting, he doesn't give us directions for how to find out what the simple natures are and what the simple motions are. Your suggestion, the pragmatic suggestion, that, well, we just simply go with what works, is an extremely interesting suggestion. And he might have found that attractive, but it's interesting that he doesn't mention anything like that. Or does he?
By saying knowledge is power, and what is it in speculative philosophy, and axiom should be an operative or rule.
Yeah.
He kind of suggests that if the rule works, then that should be the axiom that we put in speculative philosophy. Of course, it's not so simple, but
But the thing is,
seems to that.
but the thing is, you are about to do a Baconian methodological investigation. You want to find the form. In order to do that, you have to say, well, what is my goal? It is to find the form of a simple nature. But in order to do that, you need to know what are the simple natures.
Yes, but at the same time,
But Doina, so we can have time.
We can
Everybody.
continue this discussion.
So we will continue with Raya.
no, ask it. So
Okay, so Silvia.
So just one. It's about forms. When we talk about these comparative tables, the result would be that forms are more in some instances and less in other instances. So I wonder how that is possible, and how do we understand that? I'm not sure that is the way in which a form is. When a form is present, the form simply is. And I would suggest that the intensity is another question. I mean, how do you, it's very tricky thing. So it's not
Yeah, it is.
simple, but, do you think that he would say that so there is more form of heat in fire and less form of heat in, I don't know.
Well, actually, when you look back at this is on page 3, the table of degrees or comparison in heat. And he talks about in which the nature under inquiry is found in different degrees.
Yeah,
Right.
nature.
The nature is found in.
But here's the point. I think that when the form is present in the body, the nature is present, but the nature is not the same as the form.
Yeah.
And then I think that the nature can have different intensities, but it
The
would
form cannot
different
have-
forms, because it wouldn't be more form, but more intensity. I'm using this word because in other passage, which I'm going to talk about this today, it resorts to the theory of latitude of formality. So
Yeah.
the scholastic, so is some, I don't know how loyal is to the scholastic doctrine, but
Yeah.
it seems to me that wouldn't be that, so it's not
Yeah.
less form, but less intensity of the same nature.
Yeah. I mean, it's a very difficult thing.
Yeah.
I think what he would say, for example, is, okay, if you look at the form of heat,
Yeah.
he says the first difference is heat is an expansive motion, whereby a body strives to dilate and stretch itself. And you could say that some things strive to expand themselves with more intensity than others.
Yeah.
For example, boiling water less so than exploding gunpowder. And you might, in that case, say that the form is more present in exploding gunpowder than it is in boiling water. I don't know. I don't know. But I'd be interested in hearing, I mean, you have an advantage because you've heard my presentation, but I haven't heard yours. But I'd be very interested in seeing the passage that you
Part of the
present.
difference, I think, is
Yeah.
between physical causes and metaphysical causes, but so.
Okay, so we have still two more questions. It will be Sarah and Leonel.
Well, actually, Dan, you've already more or less answered my question by answering Dorin's question, so I will pass.
Okay, so we pass to the last one.
So if we arrive to this idea that motion, that heat is motion, how can we advance towards the next step, which is generating or superinduce this nature to another?
How is it that we actually generate?
Yeah, does it have to do with magic, or what kind of magic would this be? I don't know.
Well-
See what's the
Remember, magic is, when Bacon uses the term magic,
yeah.
it is just simply, it is metaphysical engineering. It's imposing natures on things by knowing their true forms. But he doesn't tell us here how exactly it is that we could actually,
Yes.
but that's the kind of magic that's involved is, when we know the true forms of things, and when we really know them, then we'll know how to impose them on things. Then we will be able to have control of nature through knowing the forms, which is what magic is. But he doesn't really tell us.
Okay.
He just says, if we knew how to impose them on, then we would be able to control nature in that way.
Okay, well, we are, thank you very much, Dan, for everything. Y ahora continuamos con la ponencia de la doctora Laura Benítez.